So this is your last lesson that you're going to have to watch and do on Google Classroom. And this one's about Worksheet 12.3, which goes over probability. So the first thing we're going to talk about is what are the two components of a probability model. So the first thing we're going to know is that there's always a sample space. Set S with all possibilities can occur. Each element of S is called an outcome. The second thing we need to know about probability assignment is probability that each outcome has to be a non-negative number, which means it has to be positive, and the sum of all the probabilities must equal 1. So when you add up all the decimals, it can't be less than 1, it can't be more than 1, they all have to add up to 1. So example number 1 says, an experiment consists of rolling a fair die once. A die is a cube with a face of 1, 2, 3, 4, 5, or 6 dots. The sample space would be 1, 2, 3, 4, 5, and 6. The probability assignment. So the probability of rolling a 1 would be a 1 out of 6. The probability of rolling a 2 would be a 1 out of 6. A 3 would be a 1 out of 6. 1 out of 6. 1 out of 6. And 1 out of 6. Notice these are all positive numbers. And 1 6 plus 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 1 6 adds up to 6 over 6, which adds up to 1. Number 2, an experiment consists of tossing a coin. The coin is weighted so that heads is 3 times as likely to occur as tails. Well, the first thing we're going to do is assign the sample space, so I can have heads and I can have tails. And this is a little different because it's weighted. So what we're going to do is I know that the probability of getting a head is going to be 3 times as likely as the probability of getting a tail. Well, I don't know what the probability of tail is, so we're going to say the probability of getting tail is equal to x. So the probability of getting a head is 3 times that. And then I know that when I take these two probabilities, 3x plus x, it has to add up to 1. So 3x plus 1x gives me 4x. So x is equal to 1/4. And remember, x is the probability of getting tails. So flipping the coin, it is 3 times as likely to occur on heads. The probability of getting tails is 1/4. So the probability of getting a head would be 3 times that, which would be 3/4. So let's just double check our math. These are both positive, and 3/4 plus 1/4 adds up to 4 over 4, which is 1. You're going to have a problem just like this to do in your homework. You're going to set up just like I just did. Probability of equally likely outcomes. So on example number 3, it says calculate the probability that in a 3-child family there are 2 boys and 1 girl. Assume equally likely outcomes. So the set, you always start off with what is my sample space. So I could have a boy, boy, boy. Then I could have 2 boys and then a girl. I could have a boy, a girl, then a boy. Or I could have a boy with 2 girls. I could have a girl first and then 2 boys. I have a girl first, a boy, then a girl. I could have 2 girls in a row and then a boy, and then I could have girl, girl, girl. You're going to need this sample space for another problem in your homework, so just remember to go back to this. And they want to know what is the likelihood of getting 2 boys and 1 girl. So this right here is 2 boys and 1 girl. This situation right here is 2 boys and 1 girl. And the situation right here is also 2 boys and 1 girl. So that's 1, 2, 3 possibilities out of, how many are my sample set? 1, 2, 3, 4, 5, 6, 7, 8. So there's a 3 out of 8 chance that I could have 2 boys and 1 girl. And again, you're going to have a problem just like this in your homework, and I want you to go back to this sample set and use it again. Now we're going to do compounded probabilities. So there are some rules over here. And we did a rule just like this, I think on the first worksheet, 12.1, we were talking about unions and intersections. So the probability of E plus the probability of F minus their intersection will give me the union. So here's an example of doing that right here. So they want to know what is the probability of E union F. And they tell me that E is 0.2, F is 0.3, and the intersection is 0.1. So I'm just going to plug into this formula up here. So they say take the probability of E, which is 0.2, plus the probability of F, which is 0.3, minus the probability of the intersection. So 0.2 plus 0.3 is 0.5, and 0.5 take away 0.1 is 0.4. We also have mutually exclusive events, and if something is mutually exclusive, you simply just add them together. So if I said that E and F are mutually exclusive, and I said the probability of E is 0.7, and the probability of F is 0.3, I would just add those up and I'd get 1. The complement of an event. So they say if you have a sample space S of an experiment, E is an event, the complement of E, and we talked about this on the first worksheet, the complement denoted with E with a bar or line over it is a set of all outcomes in the sample space S that are not in the outcomes of E. So you're simply going to subtract it from 1. Because remember, our probabilities have to add up to 1. Alright, so here's an example of what we just talked about over here. It says let E represent the event roll of an odd number. So what are my odd numbers? What's my sample space here? So 1, 3, and 5. So that's my sample space, which tells me I have 3 numbers that are odd. F is going to represent the event of rolling a 1 or a 2. So 1 and a 2, that has a sample space of 2. The first thing they want me to do is write the event E and F. Okay, well here's E and here's F. And they want me to, if I'm going to have the event of E and F, that's going to be the union. And that means, I'm sorry, if I write the E and F, that's the intersection. Sorry. I was looking at the second one. And the intersection of these two is simply 1. Write the event of E or F. That means it could be in either one. That's the union. This is when I write them all. So 1, 2, 3, and 5. So this only had 1 number in the set. This had 1, 2, 3, 4 numbers in the set. Alright, so now they want me to compute the probability of E and the probability of F. Well, the probability of E is going to be 3 out of 6. We're talking about a dice. I have 3 odd numbers out of 6, which would be 1 over 2. The probability of getting a 1 or a 2 would be 2 out of 6, because again, there are 6 spaces on the dice, which would be 1/3. Then they want me to compute the probability of E intersect F. So the probability of E intersect F, well, intersecting F only had one time it could occur, so it's 1 out of 6. E union F had 1, 2, 3, 4 things that could happen out of 6, which is 2/3. The last example says the weather report stated the probability of rain tomorrow is 40%. What is the probability that it will not rain? So we're going to use the complement event over here. If it's 40% chance it will rain, then 1 minus 0.40 would tell me what's the probability that it won't rain, which is 0.60 or 60%. Alright, so now what we're going to do is we're going to do some problems together on the worksheet, and then I'm going to assign some for you to do for homework. I'm also going to get rid of some, and then you'll take the quiz, and then you'll be done with this unit. Okay, so 5 and 6 simply just want to know if these were probability models, which ones are allowed to be probability models and which ones cannot be probability models. So remember, we said it has to be less than 1, and it can't be negative. So 1.5 can't be it. It's too big. 1/2 is okay. 3/4 is okay. 2/3 is okay. 0 is even okay. But the negative is not. So when they ask you which of the following numbers could be the probability of an outcome, it has to be less than 1, and it can't be negative. 0 is okay. 1's okay. And all these fractions that are less than 1, they're all okay. So every single one of these would be a probability outcome. And I'm going to let you go do 5. You're going to do it the same way. Alright, so now we're going to go look at number 9. Determine whether the following is a probability model. Okay, so we're going to start off the same way. All these numbers are less than 1, check. None of these are negative, check. Now I need to know, do they add up to 1? So when I add all these up, I should get 1. 0.3 plus 0.2 is 0.5. 0.5 plus 1 is 0.6. 0.6 plus 3, these add up to 0.9, so no, it's not a probability model. If this had added up to 1, then we would say yes, it is a probability model. Okay, so you're going to go do 5 and you're going to go do 7. Let's go look at 11 and 13. So in 11 and 13, they want me to construct a probability model for each experiment. So on number 11, they want me to conduct the experiment of tossing a fair coin twice. So one possibility would be having heads and heads. So then I could have a head and a tail. And then I could have tails and then heads. And then I could have tails and then tails. So how many different situations did we have? 1, 2, 3, 4. So I have 1/4, 1 out of 4 chance of getting a heads tails, 1 out of 4 chance of getting a tails head, and a 1 out of 4 chance of getting a tails and tails. And that's all I have to do. So you're going to do the same thing for number 13. On number 13, you're tossing 2 fair coins and a dice. So I'll help get you started. So you might get heads, heads, and 1. And then you might get heads, tails, and 1. You might get tails, head, and 1. You might get tails, tails, and 1. Okay? Then you might get head, tails, you might get head, head, and roll a 2. And head, tails, and roll a 2. And tails, head, and roll a 2. And tails, tails, roll a 2. And I think you can see the pattern. So just extend this pattern out and finish it up. I'm going to go ahead and get rid of 15. Doing this twice is plenty. Now let's go look at 17 and 19. On 17 through 21, they want me to use spinner 1, spinner 2, and spinner 3 to answer the questions. So I'm going to let you do 17 and I'm going to do 19. So you're going to do 17, I'm going to do 19 with you right now. It says spin spinner 1, then spinner 2, then spinner 3. What is the probability of getting a 1 followed by a red or a green followed by a backward? So we actually have 2 different situations. They want to know what is the probability if I spin spinner 1 that I get a 1, a red, and a backwards. So that's one of them I'm going to do. So the probability of getting a 1 is 1 out of 4. 1, 2, 3, 4. The probability of getting red is 1 out of 3. And the probability of getting backwards is 1 out of 2. And this is if I get the red. And that would give me 1 over 24. Now I'm going to do the second situation. What's the probability of getting a 1, a green, and a backward? So I still have 1/4 for getting a 1, 1/3 for getting a green, and 1/2 for getting it backwards. So I have 1 over 24 again. And I'm going to add these 2 together, and I get 2 over 24, which reduces to 1/12. And you're going to do the same thing for number 17. They want you to spin 1 and 2. They want the probability of getting a 2 and a red, and then the probability of getting a 4 and a red. So you're going to set it up exactly the same way. We're going to get rid of 21. And now we're going to go look at this table right here. So 23 through 25. Consider the experiment of tossing a coin twice. The table lists 6 possible assignments of probabilities for this experiment. Using the table, answer these questions. Well, the first question on 23, it says, which of the assignments of probabilities are consistent with the definition of probability model? So I'm going to do part of this with you and let you finish it. So I'm going to go look at assignment A. 1/4, 1/4, 1/4, 1/4. Those are all fractions. They're all less than 1. None of those are negative. 1/4 plus 1/4 plus 1/4 with 1/4 adds up to 1. So A definitely works. Let's go try B. 0 is okay, 0 is okay, 0 is okay, 1 is okay. 0 plus 0 plus 0 plus 1. B is okay. So that's all you're going to do is you're going to go through and check to make sure that they're all less than 1, that none of them are negative, and they all add up to 1. So there are 2 more that should be here. So you need to go find the other 2. 25 says, which of the assignments of probabilities should be used if the coin is known to always land on tails? Well, there's only one of these assignments where it's always a tails. So this says always tails right here. So which of these assignments is it always going to be tails? Well, it's going to be tails, tails 1/4 of the time here. it's going to be tails and tails, hey, right there. So the time that it's always going to be tails is assignment B. Okay, remember, you got to go finish 23. Finish. All right, 27 is just like the one we did in our notes. Remember I said I want you to go back and do one like in our notes? So you'll notice up here, I showed you how to do it. I want you to go try it. You're going to go figure out for a weighted situation, okay? So when you're doing 27, you're going to go do 27. You're going to do exactly like example 2. Okay, 31. So 31 says, compute the probability of event E. And this is my sample set up here. So notice event E has 3 objects in it. And the set has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of getting a 1, 2, or a 3 would be 3 out of 10. Okay. 33 wants me to predict the probability of getting an even number. So 1, 2, 3, 4, 5 of them are even out of 10. Okay, you're going to do the same thing for 35 and 36. Same type of problem. You have 5 white marbles, 10 green marbles, 8 yellow marbles, and 7 black. So first thing you're going to do is find out how many are total. So 5 and 10 is 15. 8 and 7 is 15, so there are 30 marbles total. All right, 37. This is the one where I told you you're going to want to use this set again when you worked your homework. So when you're doing 37, you're going to come back to example 3. We've already listed the whole sample set. You're going to use this again to answer the question, what is the probability of having 3 boys? So don't go make a new set. Use the sample set right here that we already did. All right, so let's go look at 41 and 43. 41 wants you to determine the probability that the sum of 2 dice is going to equal 7. Right, well, the first thing you have to figure out is how many possibilities are there if you roll 2 dice. Well, there are 36 possibilities because there are 6 faces on each dice, and 6 times 6 is 36. But I want to know how many times will it add up to 7. So the way I can get 7 is I can roll a 2, and then I could roll a 5. I could also roll a 5 and then a 2. I could roll a 1 and a 6, and I could roll a 6 and a 1, a 3 and a 4, and then I could roll a 4 and a 3. Why wasn't there 6? So 1, 2, 3, 4, 5, 6 different ways of getting 7 out of 36, which gives me 1 out of 6. You're going to do 43 the exact same way. All right, so for 45, they are telling me the probability of A is 0.25 and the probability of B is 0.45, and they want me to find the union on 45. So we're using the rules that we learned on the front. I'm using these formulas right here. So I'm going to use this one right here. It's telling me to find the union, and I know the union equals the probability of E plus the probability of F minus the intersection. So I'm going to take the probability of A plus the probability of B minus the intersection of their probabilities. So the probability of A is 0.25. The probability of B is 0.45 minus their intersection. Okay, and I'll let you go ahead and figure that out. That shouldn't be too hard. Okay, 47 wants me to find the probability of the union if they're mutually exclusive. So again, I'm going to go back up here and look. And it says if 2 events are mutually exclusive, you simply add their probabilities together. So you're going to take the probability of A, which is 0.25, and you're going to add the probability of B, which is 0.45. So again, I'll let you finish that without me. And then I'm going to go ahead and let you do number 49 on your own. All right, so that gets us to our last worksheet of 12.3. So let's recap on which ones you need to go do. So on the front, you're going to go complete 5 and 7. We did 6 and 9 together. We did 11 together, and you're going to go finish 13. You have to finish it. It's not done. Number 17, you're going to go do. We did 19 together. I told you you could get rid of 21. 23, you still need to finish. We did 25 together. I asked you to go do 27 using your notes. Remember I told you, go back and look at example number 2 right here, where I showed you how to find it if it was weighted. Okay? We got rid of 29. We did 31 and 33 together. You're going to go do 35, 36, and 37. When you do 37, again, you're going to go back and use the sample set from our notes on example 3. This was our sample set, boy, 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 girl, boy, girl, boy, blah, 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 blah. Remember, there were 8 total in here. We did 41 together. I want you to go finish 43. You need to go finish 45, finish 47, and do 49. Once you've completed the worksheet, then you're going to want to go take the quiz. You're going to want to check your worksheet with somebody else before you take the quiz to make sure that you understand and ask me questions if you don't. And then once you take the quiz, make sure you hit submit so I can record the grade. All right, guys, we're all done this year. All we have left is the finals.